So in class, we've already talked about determining our null and alternative hypothesis. And we've also discussed that the math inside the set of notes is not going to be any different. So what we're going to do is formalize it by actually going through a certain amount of steps to go through and evaluate, are we going to believe the null hypothesis or the alternative hypothesis more based upon my data. So first of all, whenever we're doing a hypothesis test, whether we're in the current set of notes looking at a categorical variable, or as we move throughout the semester and work with other types of data, we do the same 5 steps I'm always going to do. They're just going to look a little bit different inside of them. So when I look at my very first step, it's exactly what I would expect to do. The first thing I'm always going to do is figure out what my hypotheses are. So basically that just means I'm going to figure out, well, what is my HO? What is my HA? So I'm just going to figure out what those two things are. And again, remember, to figure out the alternative, we're going to be reading the question to sort of determine what the goal is. The second step is always going to be the decision rule, and this is the one that probably most of you have been wondering, how far away do I really need to be before I'm going to start sort of raising that flag or be concerned with what I'm working with. So this decision rule is something that I want to create before I've ever even collected the data, so that I know, this is when I'm going to raise that red flag. Such as the example we worked with in class, we were saying, okay, I wanted to be at least 2 standard deviations away. Well, we're not going to initially always do it that way. This decision rule is going to be more based upon a probability. So this decision rule is going to be to reject the null hypothesis. Or basically, we're not going to believe the null hypothesis anymore. And instead, we're going to believe the alternative hypothesis if our p-value, that probability that we're calculating, remember we talked about these terms in class, is less than that alpha, which is our new symbol, that significance level. Or in a sense, again, how unlikely do I want something to be? So maybe I might say, well, I want it to be less than a 5% chance of it happening. Maybe I want it to be less than a 1% chance of it happening. And we'll talk about kind of why we would set this number to be a different number, depending upon the question that we're working with. Step 3 is always going to be to check our appropriate conditions and calculate a test statistic. We're going to look at these more specifically for our type of problem on the next page. Step 4 means we're actually going to calculate that p-value, calculate that probability, and make our decision. Now, what do I mean by making our decision? Once we've calculated a p-value, I'm going to have a number. And I can take this number back up here to step 2 and say, okay, I have this number. Is it less than this number? If it is, I'm going to reject the null and believe the alternative hypothesis. If it's not less than my significance level, I will not reject the null hypothesis and I will not believe the alternative. And again, I know a lot of this will make more sense as we do a couple actual examples. Step 5 is actually to write our conclusion in the context of the problem, and we're also going to interpret our p-value. I have a couple of examples of how we're going to do that, but again, as we do an example, I'll kind of come back and reference these here as well. So first, if we look at these 5 steps and how they're going to relate to this specific set of notes. By that I mean we're doing a 1 proportion z-test, is what I call it up here, or basically we're working with one categorical variable. That's all we have talked about right now, so this is always going to be what my steps look like. But again, as we go throughout the semester, these 5 steps will look different inside of a different context. So when I first look at our step 1, which is determining our hypotheses, my null hypothesis will always look like this. It's p equals p0. So the first thing I want to note about this is notice that I will always have this equality sign here in the middle. Never anything else. When I'm actually doing a problem, this p0 will actually be a number. So thinking back to some of the examples you saw before, right? So we might have had, okay, p is greater than, sorry, p is equal to 0.5, for example. Now, when I'm looking at the alternative hypothesis, what I want you to note is that that P0 shows up here as well. It'll be the same number I have here. If I have 0.5 here, I'm going to have 0.5 here. Then the only difference between options A, B, and C is which sign is going in the middle. So I can either have a not equal to, a less than, or a greater than. And again, how do I pick that? I have to choose based upon the goal. So am I trying to see, is it less than 50%? Am I trying to see if it's greater than 50%? Or do I just want to see if it's different from 50%? That decision rule is going to be exactly the same every single time, but it's good practice to write it again. So we are going to reject the null hypothesis, basically not believe it, and instead believe the alternative hypothesis if our p-value, that probability of our data happening, is less than our significance level of alpha. Step 3 is our conditions first. These are what our conditions look like, which are very similar to what we had from a sampling distribution. We still need this relatively random and unbiased sample. And before, we had n times p and n times 1 minus p had to be at least 10. The only difference here is that I have that little sub-zero on my p. And the main reason that is there is that, this number I'm going to plug in here is the same number that I have up here. So it's going to kind of tell you to plug in that number down here. The test statistic is basically, again, our z. So first, just writing the z that we had back in our sampling distribution notes looked like this. And the only thing that's going to change in here is that all of the regular p's, not the p-hat, but the regular p's have that little sub-zero on them. Again, saying that this number is whatever this number is I have up here. We're going to calculate our p-value. For the p-value, again, we need two different things. I need to know my z, my actual number I just got above, and then I need to know my alternative hypothesis, because this is going to tell me which way to shade, or how do we shade the picture. Is it going to be a one-tailed or a two-tailed test? Those different types of things. And then we'll make our conclusion and interpret our p-value. Alright, so this is all great, but let's actually do a real example. So when we did our lab with the Oreos and the generic cookies, we're going to actually go through and do this hypothesis test for that. So the first thing we have to remember is some of the stuff that we had collected then. So what we knew is that we had sampled, we only had 63 students, and our p-hat, so how many of the people got the right cookie identified as the Oreo, was 44 out of that 63, which was 0.6984. So there's sort of my data that we had. Now, in our notes, we had already talked about what the hypotheses would look like. So my very first step is just going to be writing those down. So bringing up those notes, this is what our hypotheses were going to look like there. So our null hypothesis was that p equaled 0.5, because they couldn't tell the difference. They were just guessing and getting the cookie correct. Our alternative is that we wanted to see that more than 50%, or since they can tell the difference, because they're doing a better job than guessing. If they did less than 50%, they were even doing worse than guessing. Alright, so that's why we're only looking for that greater than option here. So I'm just going to write those down. So again, the null hypothesis was that p equaled 0.5. Our alternative hypothesis was that p was greater than 0.5. Now step 2 is our decision rule. So we are going to reject the null hypothesis and believe the alternative hypothesis. If our p-value is less than alpha, Now what I'm actually going to need is I'm going to actually need a value for my alpha. I didn't give us a specific one here, and we will generally talk about why we use a different one. But the majority of the time I'm going to give you one in the problem. So how we determine this is based upon many different things. We're going to use the standard as the definition told us, and we're going to use that 0.05. This is sort of the standard one if we don't have another one to use. And since we haven't talked yet about how we might change that number, we're going to use the standard value for now. Alright, step 3 is first part is going to be checking our conditions here. So let's make sure we know which numbers are which. I need an n and I need a p0. So my n is my 63 that I have up here. My p0, again, this number that shows up in that null hypothesis. So this 0.5 is going to be my p0. Right, first we'll talk about our sampling method, which we discussed in class about making sure we were doing things like we had people close their eyes when they were eating the cookies. We randomly assigned which cookie they ate first. All right, so we talked about making sure we did this in a pretty good manner. So we should be good with thinking our sampling method was all right. Then we take our n times our p0. Again, our n was just our 63. P0, again, just the number that shows up here in the null hypothesis. So that's going to be our 0.50, which means we're going to get 31.5, which is at least 10. And then our n times 1 minus p0 will be 63 times 1 minus 0.5, which is also 31.5, which is at least 10. Right, the next part is to calculate our test statistic. So we already have all of our numbers. Our p hat we had calculated, right? That's going to be our 0.6984 that we had. Our p0 is at 0.5, and our n is at 63. So we have everything to plug in. How this was different than the previous set of notes is that generally we had already calculated that standard deviation separately, which we haven't done yet. So you're going to see me plugging in all of those numbers here. So we're going to have our p0, or 1 minus p0, and our n. So some of you will be able to do this math okay. Again, I'm going to kind of show some work as I'm going here to help. So that top part should be 0.1984. And the bottom part where we're doing that square root, we would get 0.0630. So you do that number we had found separately. Now I'll actually do my division here. So we're going to get a z of 3.15. Right? Our next step is to calculate our p-value, and the two different things I need for that is z and my alternative hypothesis. Now, as I said, the math inside here isn't any different, so let's think about what this would have looked like in the previous set of notes. Right, so in my previous set of notes, I would have drawn my picture. It would have been centered at P. And then I would put on here my increments for my standard deviation. So there's the ones to the left. And our ones up here. Would look like that. Now we'll take that number we just found, right, our 69.84%, put that on here, which is a little bit up here. And then we're trying to find the probability of doing better than that, so I would have shaded to the right. So that's what we've done in the previous set of notes. Now how is this a little bit different versus how is it the same? Now if I'm looking at my picture, right, I can tell my z is 1, 2, 3, a little bit more than 3 standard deviations above the mean. That's why I'm getting a z here that's a little bit more than 3. So really all I'm going to do is I'm going to take this picture and write it in a slightly different way, now looking at it based upon z. But let's see how that picture really is still the same thing. If I look back here at my equation for this, I'm just going to plug each of the numbers along the bottom I had in here for p hat. So I'm going to plug in the 0.311, the 0.374, the 0.437, each of these numbers in for this formula where I have this 0.6984 and see what I get out. Now when I do that, my 0.5, I'm going to take 0.5 minus 0.5. That ends up being a 0. I plug in my 0.437. We're going to get -1 because we're 1 summation below the mean. We plug in our 0.374. We're going to get a -2 because we're 2 summations below the mean. And I plug in that 0.311. I'm going to get a -3 because I'm 3 summations below the mean. And just as similar, I'm going to get the 1, the 2, and the 3. Now I'm going to take this number, put that on my picture. And now because my alternative hypothesis has that greater than sign in it, that's going to tell me that I'm going to need to shade to the right. But notice how these pictures really are communicating the same information. All we've done up here, we drew the picture, found the z, went to the table. Here we're finding the z, drew the picture, and going to the table. That's the only real difference is the order that we're doing it in. And the reason why we want to get to the point where we're doing this one is z is always the same. -3, -2, -1, 0, 1, 2, 3. It's the same numbers along the bottom every single time. So if I have to do this math each time, if I understand how this comparison is going on, it makes it a lot easier. So I'm going to go to my table. I'm going to look up that 3.15 in the table. And I look that value up in the table, and let's see what we find. We find 0.9992. And we look that number up in our table. Now when I'm looking at my picture here, what we would have done before was said, well, the probability then, since it's shaded right, is going to be 1 minus our 0.9992, which is 0.0008. Get my ring here for it. But that's what I would have done before. Same thing. This just now is given a new name, and it's called a p-value. That looks a little messy to you all, so I'm going to rewrite that. Okay, all the math is done up to here. Now that I have my p-value, I'm going to go back here to step 2. So it is 0.0008 less than 0.05. Well, yes, it's less than that. So because of that, I am going to reject the null hypothesis and believe the alternative hypothesis, just as step 2 tells me to do. If this is less than that, I'm going to reject the null and believe the alternative hypothesis. So that's exactly what I'm going to do. So what step 5 is asking us to do is to take everything that we just did, but put it in context as well. So let's do both interpretations here for step 5. So step 5 tells me to take the conclusion and interpret the p-value. And here's where I have an example of each. So we're going to do the first one here first. So we have our alpha, which is 0.05. Then I have to say whether it is or isn't statistically significant. Now, when we talked about this term, statistically significant, before, it basically means that you rejected the null hypothesis. So we're going to use this is if we did reject the null hypothesis. We will choose the isn't if we do not reject the null hypothesis. And then the last thing we're doing is putting the alternative hypothesis in words. So let's see how this translates to our problem. So our alpha is 0.05. We did reject up here, so I'm going to say there is. So that should be an S and not look like a 5. There is statistically significant evidence to support we have everything up into here. Then our last thing is that the alternative hypothesis, but in words, not in symbols. So what were we trying to say? We wanted to say that P is greater than 0.5. What did that actually mean? That people could tell the difference between the Oreo and the generic cookie. So that's exactly what I'm going to say here. So there is evidence to support that we could tell the difference between the Oreo and generic cookie. That's what that first interpretation would look like. The other one is very similar to what we did in the previous set of notes. We have this assuming, which basically is replacing my word if. The null hypothesis is true, so you're going to see this is very similar to what we had before, but there's a slight change in it. So assuming the null hypothesis is true. Now before, in the previous set of notes, I would have wrote this in a slightly different way. So assuming, I would have said, if 50% of the people would guess which cookie was the Oreo. Well, I'm saying the same thing if I say assuming P is 0.50. What this 0.50 actually means is 50% guess which cookie is the Oreo. So assuming that that is true, the probability, and then normally I was interpreting this picture in the previous set of notes. So I would have the probability that at least 44 of the 63 people identified the Oreo correctly is 0.0008. I'm no longer going to interpret this picture because it changes based on every problem I'm working with. Instead, I'm going to change based upon this picture and interpret this one instead. So I'm going to say the probability that our data was at least 3.15 standard deviations above that. And what am I referring to when I say above that? That's 0.5, right? And we were 1, 2, 3.15 standard deviations above that is Our 0.0008, again, preferred percentage, would be 0.08%. So a slight difference in this interpretation. We're getting to the point where we're making it a little bit more general, so that hopefully after having done it so much in the previous set of notes, just writing out what this is in words every single time, that we can get to the point where we write this in symbols, but you really know when I say P equals 0.5, I'm saying that 50% of the people guessed which cookie was the Oreo. Like, that's what I'm saying when I say P equals 0.5. Now, of course, this is not going to be the only example that we do. But so now looking at what we found, so from our sample that we took, we are pretty sure that people can tell the difference between Oreo and generic cookies. I'm going to do lots more practice in class.